Everything you think you know about calories and food is wrong. My promise in this short video is to help you understand why calories have nothing to do with metabolism, really, and why you need to relearn this whole area from the ground up. Meet my good friend Max German.
I've been on the carnivore diet for the last 3 years or so. Today I'm going to show you what I typically eat in a day and also discuss the changes I've made over these 3 years that have allowed me to drop 40 pounds while still feeling incredible. Totals for the day: 134 grams of protein and 214 grams of fat. And I've had a special request from none other than Professor Bart K, who's been wondering about how many calories I eat per day. So for you, Bart, my total calories are 2,462. You're welcome, Bart. Anyway, as always, great speaking with you, and I'll see you next time.
Now, Max is teasing me just a little bit. He knows what I'm about to say as well as I do, perhaps. Thanks for throwing down the challenge, Max. Here's the good oil on calories. I've been studying human metabolism and physics for nearly 30 years, and that has taught me something that almost nobody seems to appreciate. So let's go. Calories are a measurement of heat energy, which is a form of kinetic or movement energy. Okay, what is energy? Energy is a construct, which means it's something that we as humans have put together. It's an idea. It's the thing that we invoke to help us make sense of the universe as we see it. It is not directly measurable. It has no mass. It has no form, per se. When we measure energy, what we are actually doing is measuring the effects of energy on stuff. Here's an example. A calorie is detectable and measurable only as an increase to the movement, which means wiggling, spinning, and moving as a whole, of atoms in a 1 milliliter sample of water. The amount of movement is such, it is of a degree, that we perceive as being equal to an increase in that water's temperature by 1 degree Celsius. So we increase 1 milliliter of water by 1 degree Celsius, that is a calorie. So what have we measured? Well, we haven't measured energy. What we've measured is the temperature change in some water. If we rapidly combust a food sample inside a thermodynamically closed system called a bomb calorimeter. So what actually happened? Well, oxygen reacted with the food. This chemical reaction brought forth a number of photons from the electromagnetic field. These photons began immediately to zoom away at 186,000 miles per second, but they interacted very quickly with the water molecules surrounding this chemical reaction and were absorbed by the electrons around the water molecules, thus exciting those electrons to a higher energy level. Now this causes the water molecules to move, while those photons that were absorbed are then re-emitted. Action-reaction, that's a Newtonian thing. And that's what caused the water to move, and that's what we perceived as heat. As an interesting aside, by the way, these photons have no rest mass. They weigh nothing. Ergo, the absorption and emission of photons can not affect your weight. Period. Isn't that interesting? Secondly, because they have no rest mass, for those of you that have some training in physics, what that means is they cannot be brought to rest, which means you cannot absorb or consume, well, you can absorb photons, you cannot consume them. They cannot be brought to a rest, okay? So, hotter water contains more energy. Therefore, obviously, we don't need to eat any food. We just need to heat up the water in our bodies to make metabolism work, because we could just use that energy, couldn't we? So we can sit in the sun, we can sit in front of a fire, we can sit in front of an electric radiator or something like that. That'll heat up the water in our body and that'll provide the energy we need for our metabolism. Who needs food? Okay. Here on this planet, we realise that we cannot appreciably collect heat from the sun or anywhere else and use that for energy. It's the wrong kind of energy. Okay? This is the point in the video where folks who have had maybe 5 minutes of actual training in science, or those with more training than that, but nonetheless no more than 5 minutes actually thinking about the nonsense they're spewing, here's what they'll say. Yes, they'll say. It's just a measurement of energy, and energy is fungible, which is a big word meaning it can be changed from one form to another form, which is true. So there is an equivalence between heat and chemical energy, and chemical energy is the kind of energy that we do need, we're told, for metabolism. So it doesn't matter which form we're measuring, it's the same thing, it's all interconvertible. What am I talking about? Well, a couple of problems. Problem number one, while there is indeed a mathematical equivalence between calories and the chemical energy which our bodies actually do need, we're told, the body does not capture all of the potential heat energy in the foods when we oxidize them for energy. So the conversion rate is wrong. And further to this, the actual capture rate is different for carbs versus fats versus protein. So this oversimplification to saying all foods contain calories and that's near enough, it's ridiculous, it's lazy, and it's wrong. Okay? Problem number two. The idea that metabolism is indeed driven by energy, the chemical energy released from ATP, which is the thing that we make using the energy we derive from the food, chemical energy, that's also apparently wrong. When actual cellular energy requirements are carefully and closely considered by scientists, the amount of ATP that is actually used in cells, that is actually there, falls massively short of the requirements of many cells. So it actually turns out that the role of ATP in metabolism seems to be more about the role that ATP actually plays in folding and unfolding various proteins in a certain way, and it's that which does the actual work of metabolism. Nothing really to do with energy, actually. So, it seems the whole area of cellular energetics needs a total rethink. I'll do that in an upcoming video. Hit like and subscribe now so that you don't miss out when that video drops. In the meantime, here's a video you might like.